Good evening, everyone. Myself, Kumari Priya. I am a PhD scholar at IIT Roorkee, and I'll be handling this session. I'll be the teaching assistant for the course Teach Technologies for Clean and Renewable Energy Production. So, basically, in this session, what we will be doing is we will be I will be giving you a brief summary of the teachings done by Professor Mondal throughout the week. Then further we will be solving some of the questions of the previous year assignments, as well as I will be providing you some additional questions. So let me share my screen. Okay, so let us come to the content of the lectures given by Professor Mandal throughout the year. So firstly, as this is our first week, so it will be starting with a brief introduction of the subject, as well as what we will be studying further throughout the session. Then second, uh, firstly, it will be an introduction to energy. Then secondly, it will be the coal as a source of energy. And thirdly, the characterizations done to know the various properties of a coal sample. Then some of the conventional routes of energy production from coal. So let us come to the first slide, which is energy as an indicator of development. So what is basically energy? As it is basically we can say the currency of civilization, and it is basically directly related to a development of a nation. We can say that more the energy production of a nation, more developed it is considered to be. In this data, we can see here the GDP, the nations having the highest GDP, such as USA and Canada, they also show a high energy production. Whereas India, we can see its GDP is also low. Moreover, energy production in kilowatts per capita is also quite low. Therefore, for a nation to be uh, developed, we need to focus on the energy production as well. Coming to energy as an indicator of development, another continuation of it. So, what is GDP? The term we read in the last slide. What is GDP? It is basically the domestic product. It is the monetary value of all the finished goods and services provided within a country. So, it is given by the formula GDP equals to C plus G plus I plus NX. So, what is C? Consumer. It is a consumer spending. G is the sum of government spendings. I is the sum of all country business spending, and NX is the net export. Net export, that is the export minus import. Coming on to another term, that is energy intensity. It is basically the measure of energy efficiency of a nation's economy. Basically, it is the energy consumed per dollar of GDP produced. It is basically a ratio of amount of energy consumed in the production of per dollar of GDP. Another term is energy efficiency, which is completely reciprocal of energy intensity, which is the dollar of GDP produced by the unit of energy. The data here shows that the very nations having very high GDP, such as Canada and USA, they also have very less energy efficiency, whereas nations having very low GDP, such as Philippines and Bangladesh, show very good energy efficiency, and India is moderately energy efficient. Coming on to the Indian energy scenario, this is the data as of on March 2024, which shows that the total energy generation in India is 4,41,970 megawatts, and the distribution of various kind of energy sources is shown, which shows that the production of energy from coal is 48%, from lignite is 2%, gas, that is natural gas, is 6%, diesel is 0.14%, nuclear energy is 2%, hydro energy is 11%, which is also kind of renewable energy, and the total renewable energy production is 31%, which has increased almost 6% from the data which was shown in the uh, slides provided by Professor Mondal, which is data as of March 2017, which showed that renewable energy production is around 25%. And these renewables consist of solar power, wind power, biopower, biomass power, small hydro energy power, etc. Coming on to another important aspect, which is the carbon dioxide emission. Though we know that energy production is very important, apart from that, but with this increase in the energy production, another problem is faced, which is the environmental pollution and the carbon emission. So with the increasing year, with the passing time, there has been an estimate done that up to 2025 we will be seeing that China will be producing the largest carbon dioxide. China would be having a largest carbon dioxide emission. India has show a moderate carbon dioxide emission, but still it needs to be decreased. So coming on to fewer routes which we can replace from the conventional production routes of energy from fossil fuels. Conventionally, what was the route? Conventionally, we used to produce energy through combustion, which would release higher pollution, greenhouse gases, and environmental problems. Therefore, there are two ways we can try to decrease this environmental pollution. The first one is we can modify the conventional techniques, and the second one is we can introduce newer techniques. So, what is the conventional technique? Some of the ways to modify conventional technique is the feedstock cleaning, which is basically cleaning the fossil fuel or the crude, as it consists of a large amount of sulfur. So before treatment, we try to clean it of sulfur, so that during the treatment it doesn't produces large amount of greenhouse gases. Process and design modification. Basically, till now, the refineries, conventional refineries, are only suitable for the processing of lighter crude. So, what is lighter and heavy crude? Lighter crude is consisting of lesser amount of sulfur, whereas the heavier crude consists of very high amount of sulfur. So, this heavier crude is not suitable for the processing in conventional refineries. Therefore, nowadays refineries are being modified. Moreover, newer refineries which are being formulated, they are also uh, commissioned in a manner that this heavy crude can also be processed. Then third one is introduction of newer techniques, which include of various techniques such as gasification, in which instead of we can do the combustion in the presence of air, basically using the oxygen present in the air. Then the oxy-fuel combustion, that is using purely oxygen instead of air, because in air other gases are also present, such as nitrogen and various other gases. Therefore, instead of using air, using complete oxygen atmosphere. Then chemical looping is the usage of various chemicals to reduce the emission of greenhouse gases. Then direct liquefaction is converting the coal directly into liquid form, thus in turn decreasing the environmental hazards. And various other techniques such as visc breaking, delayed coking, solvent asphalting, reforming, and DME, which are involved in various, which are part of various refineries for the uh, processing of secondary crude to minimize the amount of sulfur and to transform them into more useful products such as syngas, so that it can be further used. Coming on to some of the energy sources, the which are becoming trending, very trending nowadays. The first one, that is solar energy. It is well known, the energy from the sun. Hydro energy, the energy from water. Biomass and waste to energy, energy from bio waste such as cow dung, vegetable waste, etc. Tidal and wave energy, energy from the waves waves of ocean. Wind energy, the energy from wind in wind panels, etc. And geothermal energy, which is the energy derived from the heat generated from earth crust. Moving forward, coming on to the various type of coal and its composition. Coal is basically a fossil fuel which is derived from the which is occurring in the earth crust, which is derived from the partial decay of plant materials, which is accumulated in underwater for millions of years, or swept from dry areas to underwater, and are stored there for millions of years and altered by the action of high heat and pressure. It is a combustible black or brown black sedimentary rock normally found in rock strata in layers called beds or coal seams. The geochemical process that transforms plant materials into coal is basically called coalification, and it is found in four stages. Basically, it has four ranks. The first one is peat, which is the lowest rank coal, then the lignite, then bituminous, and anthracite. And bituminous coal is further divided into subbituminous, bituminous, and semi-bituminous. Coming into the coal and its composition, the lower here we can see the different types of coal from lower rank to higher rank, along with the amount of carbon, oxygen, and their heating value and ash content. As we can see that anthracite has the highest carbon content and lowest oxygen content, and highest higher heating value, and lowest ash, whereas the lignite is the inferior kind of coal, which consists of very less heating value, as well as carbon content is very low, which clearly is the proof for the lower heating value. As we can say, as long as the aging time of the coal increases, its heating value and carbon content increases, whereas the moisture and volatiles decreases. Indian coals are mainly bituminous, lignite, and ash content in them is very high. So coming on to some of the coal reserves in India, there are basically of two types, that is Gondwana coal and tertiary coal. Coal is found in various states in India such as Jharkhand, Odisha, Chhattisgarh, West Bengal, and followed by many other countries. The, co- the total of 301.56 billion tons of coal reserves are estimated by GSI in India. So, the mainly two types of coal are Gondwana coal, which is the more aged coal, that is 250 to 325 million years old, and the tertiary coal is not that old, that is 10 to 60 million years old, and it has high sulfur content. Then what are cokes? Cokes are the solid carbonaceous materials derived from destructive distillation of low ash, low sulfur bituminous coal. Coming on to some other types of coals. Based on coking property, it is of three types: coking, semi-coking, and non-coking. Based on age of maturity, it is two types: Gondwana and tertiary coal. Some other unconventional coals are also available, which are canals and torbonites. They are basically rarely found and does not fall in any category. Coming on to some of the grades of coal, basically the grades of coals are divided depending on the amount of moisture content present in them, moisture content, content, and ash content present in them. Basically, uh, coal is used in the energy production in various industries. So, in steel industry, steel grade coal is used, and in thermal power plants, washery grade coal is used. Steel grade, and the classification is given here clearly in the table according to the percentage of ash and moisture content present in them. Coming on to the treatment of coal, by the heat treatment of coal, three categories are found. Coke, which is a solid product from the coal, which is a coke from coal. It is a grey, hard, and porous coal. Porous coal. Coke is used as a fuel, and and act as a reducing agent in smelting iron ores in a blast furnace. Coal tar is the liquid product from the heat treatment of coal. It is a brown or black liquid of extremely high viscosity which smells like naphthalene and aromatic hydrocarbons. And coal gas, it is at a when the heat treatment is done at a very high temperature and pressure, it gives out gases such as high calorific value gases such as hydrogen, carbon monoxide, methane, and volatile hydrocarbons. Coming on to some of the properties of coal, coal has caking and coking properties, good heating value, moisture content is there, volatile matter content, fixed carbon, ash content, chemical composition has CH, carbon, hydrogen, oxygen, nitrogen, sulfur, and phosphorus, and sometimes iron also in small quantity. It has porosity, caking index, swelling index, all we will be studying further. Caking versus coking. So, on applying heat in absence of air, the coal swells and leaves coherent residue. This residue is called the caking coal. In some cases, this caking coal residue possesses some metallic luster, grayish luster, and this type of this type of caking coal is called the coking coal. Coming on to the two properties, that is caking and swelling index. Caking, it gives idea about the caking property of a coal. Basically, when we apply heat, the swelling of the coal takes place and it leaves some residue which is called the caking coal, so it gives the idea about its caking property. Normally caking index for coking coal varies from 20 to 24, and for beehive oven the minimum index value would be 13 and maximum 24. And the swelling index gives the property about the swelling, how much swelling of the coal takes place. Swelling index varies from 2 to 5, is ideal for coke manufacturing. Coming on to the characterization part of the coal, it is done in basically two types, that is the proximate analysis and ultimate analysis. So, what is analysis? In proximate analysis, basically we classify the amount of moisture, that is H2O, present in the surface or inherently present in the pores, or the residual moisture present in the coal sample. The volatile matters, it is the for analyzing the amount of moisture, what is done, the sample is heated at 105 degrees C for 24 hours, then the moisture is lost. The what volatile matter may contain, may be many, may some volatile matter may also be present, which could consist of some paraffins or hydrocarbon part. So the loss in weight of moisture-free sample ignite in muffle furnace. We heat this moistureless sample in muffle furnace at 950 degree for 7 minutes in the absence of air to determine the volatile matter. For determination of ash, the weight of the residue from these two, the remaining after these two methods, this dry sample is again kept in muffle furnace at 750 degrees C for half an hour in the presence of oxygen. So we get the ash content in an open crucible. Then the fixed carbon obtained by subtracting this moisture, volatile matter, and ash percent from 100. So what we get in these three parts by my subtracting all these three parts from 100, we get the fixed carbon content. So according to the different grades, different ranks of coal, we can see that the anthracite has the lowest moisture content, and it has the lowest volatiles also. Basically, the moisture and volatiles are undesirable for good quality coal, and carbon fixed carbon content is desirable for a good quality coal. So we can see that anthracite, which is the highest rank coal, has the highest amount of carbon percentage, and the ash content, it doesn't show any kind of regular trend. The ultimate analysis is different from the proximate analysis. It is basically the elemental analysis. We can determine the amount of carbon, hydrogen, nitrogen, and sulfur present in the coal sample. The principle of CHNS is basically that it is heated, that the sample is heated. Where is my? Is heated in the presence of oxygen at a temperature of 990 degrees C. So what happens is all carbon present easily gets burned to carbon dioxide, hydrogen burns to H2O, and nitrogen burns to nitric oxide, that is NO2s. For analysis product, gas mixture flows through a silica tube packed with copper granules. This zone held at about 500 degrees C. So this mixture of NO2, SO2, CO2 and water is passed through a silica column. The mixture is held at 500 degrees C. Remaining oxygen is bound, and nitric acid is reduced, that is NO2 is reduced, and the leaving gas stream include the analytically important species such as CO2, H2O, and nitrogen. Eventually, sulfur dioxide is absorbed at appropriate traps. So what happens is we give a sample carrier gas, do the combustion here, reduction of the nitrogen is done, then the mixing of all the other gases such as carbon dioxide, moisture, and sulfur dioxide takes place, and then the separation is done and detection of the different gases, that is the separation of different elements is done here. Coming on to one another important characteristic, that is the heating value of coal. Basically, the heating value is the amount of heat released during the combustion of a specified amount of sample of coal. So it is of two types: high heating value and lower heating value. So what happens is when a coal sample, it is burnt in the presence of, or heated in the presence of oxygen. When it is heated, it releases heat in the form of flue gas. So the flue gas is released, which is further used to vaporize the water. So basically, what happens is a sample of coal consists of some moisture also. So this when the sample is heated, this coal sample on heating releases heat, and this heat is also used. Basically, this heating value is calculated using bomb calorimeter. So what happens is when this sample is heated inside the crucible in a bomb, the it releases heat in the form of flue gas, which flue gas heats up the uh, material of the bomb as well as the water bath in which the bomb is kept. So the heat is used by the bomb material as well as the water for evaporations. So after the complete operation, after the complete experiment, this water is again brought back to atmospheric temperature. So it gives back the energy, gives back, releases the energy while condensing this vapor from the water. So this uh, uh, this amount of heat is basically the higher heating value. So now what is this lower heating value? Lower heating value is basically the higher heating value subtracted by the heat of vaporization required for heat of vaporization of water. Basically given here in this formula that higher heating value equals to lower heating value plus the amount of energy that is taken from the fuel for the vaporization of water. Coming on to the bomb calorimeter, as I told, that it consists of a crucible. This is the crucible where you keep your sample. Then this bomb is kept inside this bomb, and then this crucible is kept inside this bomb. Then this bomb is kept inside this water bucket, and this water bucket is kept inside this container. So what happens is by electrical techniques, this is the thread which is there is a thread which is used for the combustion of this material of our coal sample. So by using electrical methods, this wire is burnt, which in turn burns our sample, and the heat loss from this sample, the heat generated from this sample heats up the bomb material as well as the water present, as well as the vaporizes the water present in this water bucket. So the energy, so the heat that is taken up by the material of the bomb as well as water is combinedly calculated to get our higher heating value. So bomb calorimeter is basically used for the calculation of higher heating value. But there are various other corrections which are to be made while doing the calculation of higher heating value in a bomb calorimeter. So what happens is the coal sample, it consists of various elements such as nitrogen, hydrogen, oxygen, sulfur. So when if nitrogen is present, it may get converted to HNO3, and if sulfur is present, that it may get converted. So when nitrogen is present, it may get. Just a second. So there are various corrections which are to be made. Suppose if there is nitrogen present, it may get converted into nitric acid. Sulfur is present, it may get converted into sulfuric acid. And moreover, we use a fuse wire for the combustion of our samples. So the corrections related to the fused wires are also to be made. So these are the corrections. This is a correction made for the presence of nitrogen, which is done by the addition of standard alkali solution, which reduces does titration inside the sample to remove if some kind of nitric acid is formed. Then the percentage of sulfur, if some percentage of sulfur is present in the sample, then C2 correction is to be made, and for the fused wire, C3 correction is to be made. So these are not applied as it is. Thermochemical corrections are made in the form of E1. So if nitrogen is present, then C1 calorie is the value of E1. That is, if we use a standard solution of 0.0709 normal sodium carbonate for acid titration. For E2, it is 13.7 into C2 into M, that is the mass of the sample, and E3, there are two standard there are different kind of standard fuse wires. So if we use par 45 C10 nickel chromium fuse wire, then this is the formula. And if we use 34 BNS gauge iron fuse wire, then this is the formula. And if we use 34 GA or finer platinum wire, then the value is 0. So this is the formula which after doing all the corrections we get for higher heating value. Another thing is the water content. If hydrogen is there, it gets converted to water. So water content, which is taken here, but water content, water equivalent, which is which is a characteristic of bomb, which is a inherent characteristic of calorimeter. So for finding out the equivalent water, we use a standard benzoic acid solution. So as we know that the benzoic acid doesn't consist of sulfur, therefore the E2 correction is removed, and this formula here itself is rearranged to get our water equivalent of the calorimeter in calorie per degree Celsius. Coming on to the net calorific value, for calculation of the net calorific value, as we know, we can calculate the gross calorific value from the bomb calorimeter. So for net calorific value, this is the relation which is given here. We can put the gross calorific value, and this is the amount of hydrogen present in the sample, and it is given in BTU per pound. But if we want in other units, then these are the relations. Coming on to the thermodynamic cycles, there are basically three types of thermodynamic cycles. The first one is topping cycle, then the bottoming cycle, then the combined cycle. So in the topping cycle is firstly we produce the electric power, and then the heat is recovered to meet the thermal loads of the facility. So first we provide the fuel into the furnace, then the fuel gas generated here is given to the turbine, which on expansion produces electric power. Then the heat from here is again taken. So firstly this electric power is generated, then this further is taken to the heat exchanger, where we extract the heat for the formation of steam. The bottoming cycle is opposite, where we induce the fuel into the furnace. Further, it is used. Firstly, we recover the heat from the boiler, and then this steam is taken to the this heat is used for the generation of steam, which is further taken to the turbine and to generate electric power. The third one is the combined cycle, which is a hybrid cycle. It produces both steam as well as the electric power simultaneously. So it is basically called cogeneration. This technique is cogeneration, which produces both heat and power simultaneously. And the other technique, that is trigeneration. What happens is in trigeneration, not only heat and power, along with that combined cooling is also done. And coming on to one of the thermodynamic cycle, that is the Rankine cycle, it is done in four steps. The first one is the water here. The first step is adiabatic compression. The pump here performs reversible adiabatic compression. It compresses water. Then the second step from here to 2 to 3, the isobaric expansion is takes place. This high pressure water, which is compressed from using pump, this high pressure water starts to convert to vapor. From here to here it is water, then from here to here it is a mixture of water and water vapor. As far as we go in this direction, the water starts to decrease and vapor starts to increase. So here we get complete vapor, that is complete steam. And this high pressure steam, from third to fourth, the step is that it is adiabatic expansion. That is the it goes to the turbine, where it expands and the pressure is decreased. Then this, and we get pressure is released, and further this low pressure steam or low pressure vapor is compressed to get the water in isobaric compression. Coming on to the Brayton cycle, which is also a four-step cycle. In the first one is isentropic process. The ambient air is drawn into the compressor where it gets pressurized, pressure is increased. Then the isobaric process, this compressed air then runs through a combustion chamber where it takes heat, it where fuel is burned, heating the air, and a constant pressure, and the chamber is open to flow in and out. Third step is isentropic process. The heat pressurized air is expanded here using the turbine. In and the fourth step where heat is released, it is also isobaric process. Coming on to, these are some of the factors which on which the performance of a coal-based power plant depends. That is the heating value, efficiency of the thermal processing unit, thermal efficiency of the boiler, efficiency of the turbine generator, energy requirements of the air pollution control system, and any other in place energy uses. And these are the factors influencing power efficiency. That is the pressure of the steam produced by boiler, standard at 40 bar or 600 psi, or high pressure at 65 bar or 950 psi or higher. The type of condensing device, air cooled or water cooled. The high source to preheat combustion air if preheating is necessary, steam or energy recovered on flue gas, and the number of boilers and turbines used. So let us conclude. Wrapping up the theory session, let us come to some of the questions from the old assignments. So, coming on to the first question, which of the following is not a renewable source of energy? So, it is hydrocarbon energy. In India, renewable energy sources contribute to around, the answer is 70 to 25% of electrical total electricity production. The third question is, the geothermal process in which the plant material gets transformed into coal is, it is coalification. Coming on to the fourth question, which of the following grade of coal is normally used in thermal power plant? The answer is washery grade. The swelling index helps to test the coking property of coal. The ideal value of the swelling index varies between dash for coke manufacturing. That is, ideal value is 2 to 5. The sixth question, in proximate analysis, volatile matter is measured by heating a moisture free sample in a muffle furnace at P degrees Celsius for a few minutes in the absence of oxygen in a closed crucible. Please choose the appropriate value of P and Q from the following. The answer is 950 degrees C for 7 minutes. So P is 950 and Q is 7. So coming on to this numerical. So coming on to this question, which says a coal sample with 1% sulfur is combusted in a in a bomb calorimeter. The temperature of the bucket water increases from 25 degrees C to 28 degrees C. The water equivalent of the calorimeter is 2402 calorie per degree Celsius. So this is the water equivalent, that is W value. This is sulfur content, which is the correction to be made, that is C2 correction, and the temperature difference delta T is 25 to 28, that is 3 degrees C. The 2-gram sample is used for the test, that is this is the mass of the sample 2 gram, and the par 45 C10 wire is used for the ignition. So out of 6 centimeter wire, 2.6 centimeter is used. So this is used, sorry, this is unused. So for use, we will do 6 minus 2.6. We will be getting the correction C3. To titrate the calorimeter washing, 20 ml of 0.0709 normal sodium carbonate is used. This is the standard solution, so this will be the C1 correction. So we have to calculate the gross heating value, that is the higher heating value, considering that the thermometers used are perfectly fine. They are perfectly finely working. So let us come. So this is the formula, as I during the theory session, as I told, this is the formula that we need to use. The formula for higher heating value, that is the temperature difference into water equivalent minus three corrections, that is the nitrogen correction, sulfur correction, and the fuse wire correction upon mass. So all the values are given. Temperature difference is 3, water equivalent is 2.2402. The E1 correction is C1. This is calculated, E2 is calculated by 13.7 into, this is sulfur percentage, that is C2 1, and 2 is the mass. So we get 27.4, which is written here, and E3, which is 6 minus 2.6, that will be 3.4 into 2.3, since we used par 45 C10 wire. So we get 7.82. By putting all the values in the question, we get the higher heating value, that is 3575.39 calorie per gram. Coming on to the next question, overall energy production from a power plant depends upon all of the above. Coming on to the next question, that is find the appropriate expression from the following for the overall efficiency of a power plant. That is, overall efficiency of a power plant depends on the boiler efficiency, turbine efficiency, generator efficiency, and works efficiency. So what would be the correct formula for it? So it is the first one, that is boiler efficiency into turbine efficiency into generator efficiency into works efficiency. Coming on to this question here, during a boiler trial, the coal analysis on a mass basis was reported as these are the different elemental content, that is carbon is 60.4%, which is shown here. The given is here hydrogen 9.2%, oxygen 6.5%, nitrogen 0.4%, sulfur 0.2%, and the moisture is 12.4%, ash is 10.9%. Moreover, the molecular weight of ash is given as 56, and so we have to calculate the higher heating value of coal as on received basis using the formula. This is the equation given for higher heating value, in which it is 0.3516 into carbon content plus 1.16225 into hydrogen content minus 0.1109 into oxygen content, 0.0628 into nitrogen content, and 0.10465 into sulfur content. So we have to calculate the higher heating value on as received basis, basically as we have received. So if there is some moisture or ash, we don't need to deduct it. Basically in the formula there is in exclusion of ash and moisture content. So simply what we will do, we will introduce these content amount of these. So consisting of, let us assume, 100 gram of sample. So just a second. So if we assume 100 gram of sample, then the amount of carbon will be 60.4, hydrogen will be 9.2 grams, 6.5 gram, zero point 0.4 gram, zero point 0.2 gram, 12.4 gram, and then 10.9 gram. So simply we will put the amount of different contents in the equation, and after calculation we get 35.48 megajoule per kg. Now coming on to some of the additional questions, which is the gross domestic product, that is GDP, is given by C, consumer spending, G, government spending, I is country's business spending, and N is NX is net export, that is export minus import. So what will be the formula? What is the correct formula? That is GDP equals to C plus G plus I plus NX. Coming on to the second question, which among the following countries has the highest carbon dioxide emission? So as in the class, in the theory we told, it is China, as it is shown here. And GDP formula is shown here. Coming on to match the coal type with the carbon percentage present in it. So these are different types of coal: lignite, subbituminous, bituminous, anthracite, and the amount of carbon percentage. So we have to match the correct amount of carbon content present with the correct amount of coal type. So as we know that anthracite has the largest coal content, so it will be S in 1. After that, bituminous, it will be 45 to 86%. Then less than bituminous is subbituminous, that is 35 to 45%. Then lignite, the least amount, that is 25 to 35%. So the answer is lignite is the smallest, that is 25 to 35%. Subbituminous more than that, that is 35 to 45%. Then bituminous more than that, that is 45 to 86%. And the largest amount of carbon percentage in anthracite, that is 86 to 98%. Coming on to the next question, which is with the increasing age of coal, their P increases while Q decreases. Please choose the appropriate P and Q. So with the increasing age, as I told, carbon content and heating value increases, whereas the moisture and volatiles decreases. So the correct answer is fourth one. Coming to fifth one, dash type of coal mostly found in Indian subcontinents. It is basically lignite and bituminous. Coming on to the sixth question, which is dash is the output of thermal processing of pulverized coal. So if we do the thermal processing of coal, it releases flue gas. Coming on to the seventh question, that is the net calorific value is the gross calorific value less the dash heat of water in the product of combustion when cooled. So it is basically latent heat, basically the heat which is used for the change of phase from water to vapor. Coming on to the next question, which is in proximate analysis, moisture percentage is measured by drying the sample at 105 degrees C. Coming on to the next question, that is for a coal-fired utility boiler, the temperature of high pressure steam would be about 700 degrees C, and T cold, that is cooling tower water temperature, would be 65 degrees C. Calculate the Carnot efficiency of the power plant. So this is the formula for Carnot efficiency, that is 1 minus Tc upon Th, that is the temperature of cool water upon temperature of high pressure water. So firstly we have to convert this temperature into Kelvin, as we have done here. Then by putting in the formula we get 65.2%, that is approximately 65%. Coming on to the next question, that is to determine the water equivalent of a bomb calorimeter 1.5 gram benzoic acid sample. This is the question for the calculation of water equivalent. As I told that it is a characteristic of calorimeter in which we use a standard solution of benzoic acid. So the mass of the sample is 1.5, this is 1.5 grams. HHV, that is HE, higher heating values given 8000 calorie per gram was used. The experiment produced a net corrected temperature rise of 5 degrees C, so delta C is 5. The acid titration required 12 ml of standard alkali and 8 centimeter of par 45 C10 nickel chromium fuse wire was consumed. So 8 centimeter was consumed, so this will be used, and 12 ml that is C1 correction. This is for the C3 correction, determine the water equivalent. And C2 correction will not be made since there is no sulfur present in the benzoic acid. So by the calculation of C1, it will be used as it is. There is no such formula. And E3, since pars 45 C10 wire is used, then the formula is 2.3 into C3, that is 2.3 into 8, that is the amount of fuse wire consumed. So after doing all the calculations, we have to put the value. Where is my cursor? All the calculations, putting the value here, we get a water equivalent value of 2406.1 calorie per degree Celsius. Coming on to another question, that is what is the indicator of sustainability? It is basically both A and B, that is the GDP and energy efficiency. Coming on to the next question, that is installed capacity of electricity production in India as on 31 March 2007 was. It is around 326 gigawatt, which is obviously increased by the year 2024, as I told in the slide before. It is around. Coming on to the 13th question, which is the global CO2, that is atmospheric carbon dioxide level reported in June 2017 was. It is around 409 ppm. Coming on to the next one, that is higher rating value of the bituminous coal is. It is 25,000 to 35,000 kilojoule per kg. Coming on to the 15th question, which moisture type is an integral part of the coal seam in its natural state, including water in pores, but excluding that in the macroscopically visible fractures? So the moisture present in the macroscopically visible fractures, that is the surface water, water present in the pores, it is basically the inherent moisture. The total moisture is the sum of inherent moisture and the surface moisture. Residual moisture is even after drying the sample. There is, if some amount of moisture is left, then that is the residual moisture, and the equilibrium moisture is the moisture present at standard conditions, that is 60% relative humidity and 40 degrees C temperature. So, what is true about swelling of coal? It helps to test the coking property of coal. Swelling index varying between 2 to 5 is ideal for coke manufacturing. The high swelling coal is not charged for coke making as it would create unnecessary pressure on the walls of the oven, will also produce a coke porous structure, or all of these. The answer is all of these. All of these statements are correct for the swelling index of a coal sample. So coming on to the 17th question, which is which one is not a classification of thermodynamic cycle? Topping cycle, bottoming cycle, combined cycle, or none of them? The answer is none of them, since all these three are thermodynamic cycles. Coming on to the question 18, which one is true about energy equivalent of the calorimeter? So as I told, energy equivalent is calculated by taking a standard solution of benzoic acid. So it does not consist of sulfur. So E2 correction is not present in that. So the answer is W equals to Hg into M plus E1 plus E3 by delta T. Since E2 is the sulfur correction and there is no sulfur present in the benzoic acid. Coming on to the question 19, match the following emissions from the fossil fuels through conventional routes in best possible combination. So these are the various elements present in the emission from the fossil fuel, that is the carbon dioxide, NOx, that is some amount of nitrogen dioxide, etc., then sulfur dioxide and the particulate matter. So what is subcritical, and let me explain one thing, subcritical and supercritical. So what is desirable is the decrease in the emission, that is hazardous environmental polluting emissions from the various emissions done from the fossil fuels. So basically to reduce them, as we can see, if we perform the emission in subcritical state, then the emission amount is this, then in gram per kilowatt hour. But in subcritical we can see that these emissions are reduced. So what is desirable is we want to shift to supercritical, which is not yet practiced, but if we shift to supercritical condition, then the emission will be decreased, which is desirable, which is less than 835 is less than 926, 2 is less than 2.22, 6.16 is less than 6.82, and 0.15 is less than 0.17. So basically the answer is they are correctly written: A to E, B to F, C to G, and D to H. So the answer is first one. Coming on to the last question of the session, which is a numerical, which says during a boiler trial, the coal analysis on mass basis was reported as these. These are the various elemental content percentage given here. The molecular weight of ash is given as 56. So we have to find is the molecular weight of the coal and the heating value on as received and dry basis. And the formula for high heating and lower heating value is given here by these equations, where W is the percentage of moisture and H is the percentage of hydrogen. So let us come to the solution. So firstly, let us try to solve this part, the molecular formula of the coal. So for that, for the molecular formula, we want to calculate the mole of each component present in the coal sample. So let us come here. Let us form a table and write all the contents on as received basis. So what we do, we will assume 100 gram of sample. So by assuming 100 gram of sample, we can say as the content given in the question, they consist of 5.6 gram, 56.4 gram of carbon, 3.2 gram of hydrogen, 5.4 gram of oxygen, and 1.6 gram of nitrogen, 1.1 gram of sulfur, and 15.4 gram of ash, and 16.9 gram of moisture. So this is the percentage on as received basis, and assuming 100 gram of sample, these are the mass of each element. And the molecular weight of element, as we know, of carbon 12, hydrogen 1, oxygen 16, nitrogen 14, sulfur 32, ash is given in the formula, that is 56, and for moisture it is H2O, which is 18, that is 16 plus 2 is 18. So the moles are calculated by mass of element upon molecular weight of element, that is 56.4 by 12 is 4.7, 3.2 by 1 is 3.2, 5.4 by 16 is 0.3375, as it is. Likewise, similarly, we will calculate all the moles of the different components present. So as now we know the moles, so we will be writing the formula, which will be written as C.4, C 4.7, H 3.2, O 0.34. From here we will be taking all the moles and writing down as it is. O.34, N.114, S.034, ash 0.275, H2O 0.93. So this is the formula of our coal sample. Now going to the next part, in which we have to find the higher heating and the lower heating value of the coal sample on dry as well as received basis. So firstly, let us do on as received basis. So as we have taken 100 gram of sample, these are the mass of different components. So we will be directly putting the mass of elements, different elements into the formula, such as C as 56.4, H as 3.2, oxygen as 5.4, nitrogen as 1.6, and sulfur as 1.1 in the formula, and we will be getting higher after solving. We will be getting the higher heating value as 48.3407 megajoule per kg. Then similarly in the lower heating value equation, we will be putting higher heating value and the water content, that is the moisture content, which is 16.9 plus 6.8 into hydrogen content, which is 3.2, and after solving we will be getting 46.45 megajoule per kg. So till this it is very simple. As received basis, no need of excluding any ash or moisture content. But on dry basis, what does dry basis means? It means we have to exclude the moisture content, that is minus. So for minus moisture, as we have taken 100 gram of sample, so for moisture we will be doing 100 minus this moisture, that is 16.9, that is 83.1. So for calculating each content on dry basis, it will be 56.4 as on received basis into 100 upon 100 minus moisture, that is 16.9, which is giving 83.1. So 56.4 into 100 upon 83.1, which will be giving it 67.8. 3.2 into 100 upon 83.1, which will be giving 3.85. So likewise, we will calculate all the other contents value on dry basis, only excluding moisture, since we don't want moisture here as it is on dry basis. So by calculating all these values in dry basis, we will be putting them in the formula of higher heating value, and we will be getting 59.112 megajoule per kg. And for LLV, we will be putting the value of higher heating value, then in the formula in the equation given in the question. But this w value here in the as received basis we have put 16.9, but here as it is on dry basis we will be putting it as 0. So after putting the water content as 0, we will be getting 57.834 megajoule per kg. So this is our lower uh, heating value, not LLV. It is basically LHV. Sorry for the. Okay, so this is the last question for the session. So let us end our session for the day. Thank you for your patience. Thank you, everyone.